Hi, here's yet another math lesson from us, and for today we will be exploring the topic trigonometry. To start with, we will learn about the trig ratios of obtuse angles. From there, we will move on to the sine and cosine rules for triangles. We will then take a look at a new and unconventional way of finding the area of a triangle. We will study bearing and lastly look at angles of elevation and depression. So for our next section, we're going to be studying the sine rule. Here's the sine rule. But for us to get an appreciation of this rule, we need to understand where it comes from and how to apply it. We have our triangle ABC here, which is not a right-angled triangle. However, it is made up of two right-angled triangles, ABD and CBD. This means that problems of this triangle can be solved using concepts for right-angled triangles applied to its two fragments. Using trig ratios, sine A is equal to opposite over hypotenuse, the opposite being h and the hypotenuse being c. So sine A is equal to h over c. Sine C, on the other hand, is also opposite over hypotenuse, and that takes us to h over a. We consolidate our findings from the two triangles because they make up one big triangle. We change the subject of the formula and make it h for both for the sake of uniformity. We end up with h is equal to c sine A and h is equal to a sine c. We end up with two values of h from the two different triangles. H is the same for both, meaning that c sine A is equal to a sine c. In order to get to our sine rule, we need to multiply both sides by 1 over sine c in order to eliminate the sine c on the right side. This means we are multiplying c by the reciprocal of sine c. On the other side, we do the same. A sine c over sine A, and we multiply it by 1 over sine c. By doing so, we cancel out this sine c and we end up with c over sine c is equal to A over sine A, and this forms part of our sine rule. Once we have come this far, we need to complete our sine rule. We do this by splitting the triangle into two right-angled triangles again, but this time using a different perpendicular line. When we do this, A over sine A will be equal to B over sine B, or C over sine C will be equal to B over sine B. This brings us to our full sine rule. The sine rule shows us how the angles of triangles are proportional to the sides opposite them. We can flip the formula to have sine A over A is equal to sine B over B, which is also equal to sine C over C, and it still works and we get the required results. The sine rule can be used when we are given two angles and one side, or when we are given two sides and an angle. Once we know that, we can jump straight into our example and work it out. It reads, PQR is a triangle in which P is equal to 35, Q is equal to 34, and PQ is equal to 4 centimeters. What is the diameter to the nearest millimeter of the smallest circular disc which will completely cover the triangle? For us to use the sine rule in this particular example, we need to know that sine P over P is equal to sine Q over Q, which is also equal to sine R over R. We can also flip it like we said and have P over sine P is equal to Q over sine Q, which is also equal to R over sine R. To solve the puzzle, we plug in the values that we have been already given, and that is angle P, angle Q, and side PQ. Side PQ, which is R. We have not been given the value of angle R, but we can still get this by subtracting from 180 degrees, 35 and 34 from angle P and Q. This will give us 111 degrees. This means that sine 111 over 4 is equal to sine 35 over an unknown figure. We multiply the two and get x sine 111 is equal to 4 sine 35. When we divide both sides by sine 111, we find that x is equal to 2.457, and the number goes on and on. When we round it off, we get 2.5 centimeters. We have found the length of side RQ, which is also side P, because it is angle P that has 35 degrees. Next, we do the same for side RP, which is side Q. Our sine 111 over 4 is equal to sine 34 over an unknown value. We repeat the same process, cross multiply, and we divide to remain with x. Punching this into our calculators shows us that x is equal to 2.395, and the number goes on and on. We round it off and we get 2.4 centimeters. We have successfully figured out the values of sides P, Q, and R. R is already given to us, and that's 4 centimeters. P is 2.5 centimeters, and Q is 2.4 centimeters. Now, let's assume our triangle looks roughly like this. Here we have 4 centimeters, then 2.4, and when we're looking for a disk that completely covers this triangle, we're looking for a disk whose diameter is as wide as the largest side of this triangle. And this means that this disk has to be 4 centimeters in diameter.